Hello, in this video we shall discuss about Ethernet and Fieldbus used in embedded systems. So Ethernet is a widely used local area network LAN for general purpose computing. Okay, so the standard of Ethernet is IEEE 802.3 standard, and the main features of this Ethernet are ubiquity and low cost, and because of these features it is used in embedded computing. And the Ethernet is useful in embedded systems when the personal computers or PCs are used as platforms, and also when the network does not have to meet any real-time requirements. Okay, so mainly non-real-time embedded systems use this Ethernet network for communication. Then the physical organization of an Ethernet network is shown in figure. So here you can see three nodes are there, A, B and C. They are connected via a single signal path, and the network here is a bus. So in Ethernet network, the usual network topology used is bus or star topology. Here in this figure uses a bus topology. Then different implementations are available for Ethernet, like twisted pair and coaxial cable. An important feature of Ethernet is the nodes on Ethernet are not synchronized. Synchronized means what? So see, you have seen in I2C bus, inter-integrated bus, that it is the nodes in inter-integrated bus are synchronized using SCL line. SCL is serial clock line. Okay. So but in Ethernet, nodes are not synchronized, means nodes can send their bits at any time. Now, the bus arbitration scheme used in Ethernet is carrier sends multiple access with collision detection, that is CSMA bar CD scheme. Okay, so that is the bus arbitration technique used in Ethernet. So in Ethernet, if nodes decide to transmit at the same time, definitely a collision occurs, so the message will be ruined. Okay, so if here in this figure, if A and B transmit their message at the same time, then the message pass through a single line, so the message will collide and the message will be ruined. So the CSMA CD algorithm is given in figure. So here in this figure, if a node has a data to transmit, it listens or sends the Ethernet channel, and if the channel is free, it starts transmitting data. Okay, so here it checks whether the channel is free or not. If the channel is free, okay, if it is yes, then the node transmits its data. But during channel sensing, if it hears another transmission, it stops and waits to retransmit. So here, if while sensing the channel, if the channel is not idle, then it waits for some random amount of time. Okay, then after that it again try to retransmit the data. So if the channel is free, it can transmit the data, and if no collision detected, we can say that the message transmission is completed. Okay, so if there is no collision, then the data transmission is completed or finished. But suppose two nodes want to send the data, and they both sense the channel to be free, and they transmit the data at the same time. Okay, consider such a scenario, then a collision occurs. So if they retransmit the message again at the same time, what happens is again collision occurs, right? So this leads to an infinite loop of collisions, or we can say that it leads to a deadlock state. Okay, so two nodes are trying to transmit their data at the same time, then collision occurs again. While retransmitting the data, again the two nodes try to retransmit the data at the same time, so again collision occurs. So this repeats, and it leads to a deadlock state. So to avoid this problem, Ethernet uses a technique called exponential backoff technique or exponential backoff algorithm. So we will see what is exponential backoff algorithm. So this EBA or exponential backoff algorithm is a collision resolution mechanism used in Ethernet to schedule the retransmission after a collision. So backoff algorithm defines a waiting time for the nodes involved in a collision, that is, for how much time the station would wait to retransmit after a collision. Okay. So this algorithm defines a waiting time, and this waiting time means how much time the station or a node should wait to retransmit the message after a collision is detected. So in this algorithm, the waiting time period for a node or a station is given as k into t slot, where t slot depends upon various parameters. Suppose small letter t is the maximum propagation delay in the network. Okay, so let small letter t be the maximum propagation delay in the network. Then the maximum time is given as 2t. Okay, 2 into the propagation delay of the network. This total time 2t is divided into different slots, and the duration of each slot is given as capital T slot. Okay. Then the waiting time period for a node is given as k into t slot. Okay. So what is k? K is a random number chosen between the range 0 to 2 raised to n minus 1. So k is in the range 0 to 2 raised to n minus 1. What is n? N is the collision number associated with the packet. Okay. For example, suppose node A transmits its message, its first packet or first message, and suppose a collision occurs, then the collision number associated with that packet of node A is 1. Okay. Again, suppose the node A try to retransmit the message after some random amount of time. Then again, suppose collision occurs, the collision number associated with the same packet becomes 2. Okay, it is incremented by 1 each time when a collision occurs. So that is the collision number n associated with a packet, and k is chosen in between 0 and 2 raised to n minus 1, and the waiting time is randomly chosen. So the waiting time is randomly chosen as k into t slot. So when first time collision occurs, this range is 0 and 1. Okay, that is 0 to 1. Range is 0 to 1. That means the node has to choose 0 or 1 randomly and wait 0 or 1 t slot to retransmit the message. 0 into t slot means it immediately retransmit the message without any delay, and 1 into t slot means it wait for 1 time slot time to retransmit the message. Then when second time collision occurs for the same packet, this range is doubled and become 0, 1, 2, 3. Okay, and for third time collision occurs, if for the same packet, this range is again double and become 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this repeats for each collision. So this is shown in the graph. As the number of attempts or collisions for a packet increases, the waiting time is weighted by an exponential function of the number of times the messages has been aborted. Okay, and the main disadvantage of this Ethernet is that if any node wins a collision, the main disadvantage of this exponential backoff algorithm used in Ethernet is that if any node wins a collision, then its chance to win the subsequent collision is going to increase exponentially. Okay, so if the first okay. Now, to better understand this exponential backoff algorithm, watch the following video. It explains exponential backup algorithm in detail with an example. So the URL of this video is also provided in your Linway CMS. Now let's move to the Ethernet packet format. Okay, so the basic format of an Ethernet packet is given in figure. So here an Ethernet packet starts with a 7-octet preamble and 1-octet start frame delimiter which mark the start of the frame. Okay, so the preamble is of 7-octet or 7 bytes, and the start frame delimiter is of 1 byte. Okay, and the start frame delimiter mark the start of a frame. Then start frame is followed by destination node's MAC address and source node's MAC address. It's of 6 bytes in length. Okay, both destination address and source address. Next field is either type or length field. It's of 2 bytes. Then the next field you can see here, it is payload or actual data field. So this data field, it can carry 46 to 1500 bytes of data. Okay, so variable data field is the main. Now now for this data field, the minimum payload is 42 or 46 bytes. So if the actual payload is less than that, less than this 42 or 46 bytes, padding bytes are added accordingly, which is shown as next field. Okay, padding field. So this one is padding field. So if the data field is less, or the actual data is less, some bits are padded or added with the data, that is called padding field. Then last field is CRC checksum field. CRC is cyclic redundancy check, which is of 4 bytes that allows detection of corrupted data. Okay, so this is the format of Ethernet, format of a Ethernet packet. So that so that's all about Ethernet. Next one is Fieldbus. So what is Fieldbus? Fieldbus is the name of a family of computer network protocols used in real-time distributed control. So it's a family of computer network protocols. So a complex automated industrial system or a manufacturing system, it requires networked sensors and actuators, right? Okay, so industrial systems, they require they usually contain sensors and actuators, that is input and output devices, which are networked, which are part of a network system. So this field bus provides a standard for these industrial control and instrumentation systems. That is, it is a way to connect instruments in a manufacturing plant. Okay, now there are a wide variety of competing Fieldbus standards like Foundation Fieldbus, CAN, EtherCAT, Bitbus, etc. So each of these standards have their own features and use that is beyond the scope of our syllabus. So in this video we have discussed about Ethernet and Fieldbus. Thank you.